right, now we're doing problems 6 through 9 on review day 4. Number 6 gives us a particle moving along with a certain velocity. And they want to know what the total distance was traveled from 0 to 2. Now this is a topic that I believe they're saying is not going to be on their test, but it's one that we've done many times before. So I thought, what the heck, let's just give it another try. And anytime we see total distance, that means we don't care whether we were going right or left. We want it just all to accumulate. So when we integrate from 0 to 2, we have to integrate the absolute value of our velocity. So if you remember that, great. Again, I don't think it's going to come up on our test this year, but just in case it does, we should know it. So I already have that in for y1. So I'm going to go math 9, 0 to 2, and then math number absolute value of y1 dx, and I'm going to end up with eventually, I believe, d, 2.261. But there we go, 2.261. All right, so that's not too bad. Second one says we have a function with a derivative given here. At what value does f attain a relative maximum? We're going to have a relative maximum when our derivative switches from positive to negative. So in other words, what we're going to need to do is graph this from -1 to 9 and see where it switches from positive to negative. So I have this one in y2. I'm going to go ahead and shut y1 off, so it'll only graph this one. And I'm only going to graph it between -1 and 9 so that we get an idea there. And I'm trying to see where it crosses the axis, so I'm going to go from -1 to 1. I don't really need a whole lot of up or down. I just want to know where it's crossing, and hopefully we can tell if it's coming from down to up or up to down. We'll see how it goes. So we get 2 crossings there, and then a crossing there. Now again, we're trying to see where it switches from positive to negative, right? So you can kind of see the first one here is coming from negative up to positive. Then this one's from positive to negative, and then this one's from negative to positive. So really, this is the only one that we're interested in, and it's something a little bit less than 1. And if I look at my choices, I've got the -1, that's that one there. The 7.9 is this third one. 0 doesn't make sense. There's the one that I want. All right, so again, simple little idea that we've done lots of times. We just have to graph it and check it out. All right, so that was that one. Then number 8 said the number of bacteria in a container increases at a rate of r of t. If there's 1,000 times 0, which of the following expression gives the number of bacteria in the container 3 hours? So again, it's something that we've done tons and tons of before. Always start with your initial value of 1,000 plus the integral of the rate from 0 to 3. This one was one of the easiest problems you probably had, and it's just d. And then the last one here says function g is continuous on the closed interval g of 1, 5, g of 4, 8 of the following conditions, which would guarantee that there's a number c such that g prime. So as soon as we see this guarantee and the derivative equal to 1, we're thinking mean value theorem, right? What would make the mean value theorem true? We already were told that it was continuous. For the mean value theorem to hold up, we also have to be differentiable, right? And so g is increasing. No, we don't need it to be increasing. G is differentiable. There's our condition. G has a maximum value on the closed interval. No, that's an issue of continuity. It doesn't have to be differentiable. You could have something like that. There's your maximum value, but mean value theorem wouldn't hold up. G has at least one horizontal tangent. No, it doesn't have to be true. The only thing for the mean value theorem to hold up is that it has to be differentiable, and that was B.